Today what we're going to do is learn how to draw Lewis electron dot diagrams of atoms. Now you can call them Lewis diagrams, you can call them electron dot diagrams. It's all the same thing. Now if you remember back to your Bohr diagrams of your atoms, you had the electrons in energy levels around the nucleus of the atom. The outermost energy level is called the valence shell. So this word valence is something you're going to hear a lot when we start to talk about how atoms form compounds. So the valence shell is the outermost shell, and that's going to be the energy level that we're most concerned about. And the electrons in this energy level are called valence electrons. So if somebody asks you how many valence electrons are in an atom, you would talk about how many electrons are in that outermost shell. So for example, if you remember back to when we took up the Bohr diagrams, everything in group 1 had one electron in the outer energy level, so we would say they have one valence electron. Everything in group 2 had 2 electrons in the outermost energy level, so we would say there were 2 valence electrons. So we know that the electrons in the outermost energy level are going to be the ones that are involved in a chemical reaction, and more importantly, it is the unpaired electrons. So the ones where they're just one by themselves, right? There's not 2 together. Those are the ones that are going to be causing all the trouble. So they're the ones that we're going to be most concerned about when we start to do some bonding. So since the rest of the electrons in the innermost energy level, if there's 2 in there, everybody's happy. If we look at the second energy level and there's 8 in there and they're all paired up, everybody's happy. So those innermost energy levels really don't have anything to do with the chemical reactions that are going to be happening. So why do we have to draw out these big, great, big, long Bohr diagrams for everything? Why can't we just make life easier? Well, we can. Because since only these electrons, so only the electrons in the valence shells are involved in chemical reactions, we can use Lewis electron dot diagrams to show the atoms. So what we're going to do with our Lewis electron dot diagrams is we're only going to be worried about the electrons in that outermost energy level. So the best way to do this is to just do some examples. So with a Lewis electron dot diagram, you're going to really like these because they're very, very easy. Let's just start with something easy like our hydrogen. All right, I know this camera doesn't focus very well, so just do your best. So hydrogen has 1 electron in its outermost energy level. It only has 1 electron, but that just happens to be in its outermost energy level. So rather than drawing all the protons and the neutrons and all that kind of stuff, well, we know hydrogen has 1 proton and 0 neutrons. So let's just write down its chemical symbol. So there's hydrogen. Right? We know the inside of hydrogen is 1 proton and 0 neutrons. And since the outermost electrons in the outermost energy level are the ones that we're most concerned about, we only need to draw that guy in there. All right? So we're going to draw our hydrogen with 1 electron on the outside. That's our diagram. Let's do our second example here. Here's lithium. So lithium had 3 protons, 4 neutrons in the nucleus. It has 2 electrons in that energy level. Now those 2 electrons, that energy level is full. It's not going to react. It's not going to do anything. There's not any point in us even paying attention to them at this point. But we do have 1 electron in the outer energy level. All right? He's not paired up, and this whole energy level is not filled up with 8 electrons. So we're going to have some trouble here. We're going to have a problem with this little unpaired electron. So we're going to draw lithium. We're just going to put the symbol in the center. And then again, we're just going to put the 1 electron in the outermost energy level outside. So that's showing us that lithium, this is the electron that's going to be causing some trouble. It's not paired up with anything else. This one's going to be the one who's going to be involved in chemical reactions. Let's go to our carbon, because we always use carbon for our examples. So carbon, we have 6 protons in the nucleus, 6 neutrons in the nucleus. All right, so fine, great. We have 2 electrons in the energy level, so we know, right, those guys aren't going to be involved in chemical reactions. But look at this valence shell. Look at the outermost shell. We have 1, 2, 3, 4 electrons in that outermost shell. Right? And they're not paired. There's not 2 beside each other. So we're going to draw our carbon, and then around the outside we're going to have to place 4 electrons. So 1, 2, 3, 4. So there's our Lewis diagram for carbon. We don't care about what's happening with those innermost electrons because they're not going to react. Those inner energy levels are full. So look at neon here. All right, neon's a little bit of a sneaky one here. Look at its outer energy level. It's full, it's got 8, and they're all paired up. So neon, in reality, isn't going to be a reactive atom. It's not going to react with anything. But we're just going to draw it out anyway just to show. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that's our Lewis diagram for neon. And there's no unpaired electrons here, so neon is not going to be reactive, which makes sense because we use neon in neon lighting, and we don't want neon to be exploding and going on fire and doing all sorts of crazy stuff reacting with other gases. We just want it to be in that tube and to glow nicely. So let's take another peek here. Way up here, we'll go to sodium. All right, sodium has 11 protons in its nucleus and 12 neutrons. Its innermost energy level has 2 electrons. That's all it can take, so it's not going to react. The second energy level has 8, so 2, 2, 2, 4 pairs of 2. These guys aren't going to react. They're perfectly fine, so why do we need to pay attention to them? Well, we don't need to. All we need to pay attention to is that outermost energy level, and look at here. Here's one on its own. So we're going to draw sodium with 1 electron outside there. So this is the electron that's going to be causing trouble when we come to chemical reactions. Let's take a look at sodium now, or not sodium, aluminum now. So we've got 13 protons in the nucleus, 14 neutrons. We've got our innermost energy level with 2 electrons, full, not going to react. We have our next energy level with 8 electrons, all paired up, full, not going to react. And then our valence shell, our outermost shell, we've got 1, 2, 3 valence electrons, and nobody's paired up. So we're going to be able to do some bonding in here. We're going to have a chemical reaction because these guys are going to want to pair up, and this outer energy level is going to want to get as many electrons in it that it can hold. So let's draw the Lewis diagram for aluminum. So we're going to do our chemical symbol, which is Al. And then we've got our 1, 2, 3 electrons in the outermost energy level. Those are the guys that are going to be doing the reacting, so they're the only ones we care about. So 1, 2, 3. So those 3 electrons are going to cause us some trouble later on. Let's do phosphorus next. So we've got phosphorus, we've got 15 protons, 16 neutrons. So let's do our symbol, because we know the core has got 15 protons, 16 neutrons. We don't need to draw it out all the time. Our innermost energy level is completely full. All right, it's got the 2 electrons in it. Our second energy level has got 8. They're all paired up, so no one's going to be causing problems there. Now let's look at our valence shell, or our outermost shell. We've got 1, 2, 3, 4, 5 electrons. Now these guys here are paired up, so they're not going to cause a problem, but look at these guys. 1, 2, 3 are unpaired. We're going to have a problem here with our phosphorus. So our Lewis diagram, we're just going to draw the electrons in the outermost energy level. We're just going to draw the valence electrons. So we've got 1, 2, 3, 4, and 5. And these 2 guys here aren't going to cause a problem, but these 3 unpaired electrons are going to cause us trouble. So let's take a look at our last example for calcium. So this is a big one. Here's our calcium. Our protons are 20. We've got 20 neutrons in the nucleus, so we don't need to draw all that kind of stuff out. We know the core of that nucleus is 20 because it's got 20 protons in the nucleus. Our innermost, our first energy level, has 2 electrons in it. It's not going to do any reacting. Our second energy level has 8 electrons in it. They're all paired up. It's not going to do anything. It's completely satisfied and happy. Our third energy level here has 8 electrons in it. Look at, they're all paired up as well. They come 2 by 2. That energy level is perfectly fine. We don't need to worry about that. But look at our valence shell. Our valence shell, 1, 2, 2 electrons. Unbonded with another, or not unbonded, but unpaired with another electrons, trouble. So we're going to draw our calcium, our Lewis diagram, showing 1, 2 electrons around it. These are the electrons from the valence shell, or the outermost shell, and these 2 guys here are going to cause us trouble. So continue working on these Lewis diagrams on the periodic table worksheet. Talk later.